Welcome. In this video, we are going to learn through various scenarios that you might have to deal with once you've built a sensitivity report in Excel. So you might have used a linear optimization algorithm to actually build an optimum solution. If you remember, we were solving for this hot tub manufacturer building Aquaspa, Hydrolux, and Typhoon Lagoon, these three types of spas. And if you want to get a little bit more context, you should see the other video as to how we actually went about and solved this. But let's say you've solved it and now you have a decision. You're telling your leadership that you should build 122 units of Aquaspa, 78 units of Hydrolux, and 0 units of Typhoon Lagoons, and that you'd make $66,100 in profits. But then, in real life, a lot of times, a lot of things change. Like, for example, you expected you have 1,566 hours of labor. People can get sick. There could be a labor strike. Some of these pumps could turn out to be defective, or there was a shipment issue and that you didn't actually get the 200 pumps that you needed. So you want to answer a lot of what if questions. You want to answer questions like, hey, what happens if? And your boss will always ask you a lot of questions, because a lot of these certainties that we have around these are the quantities that you should be building to maximize your profits. How certain are we that this will still remain the same? As I said, what if some folks who are working at your company get sick? How would that impact my quantities that I've decided to produce, and how would it impact my profits? What if you're telling me I shouldn't be building any of these, but one of the executives is really gung-ho and wants to build one of these Typhoon Lagoons. So let's say they do build one, which is not recommended by this optimized solution. What is the downside in profits? So you want to understand that. You want to understand where should you be investing, which resources have zero slack, and by how much would you increase your profits if I, let's say, increase this limit from 200 to 201. So you want to know a lot of these questions. If I improved productivity of my laborers such that 8 hours reduced to 7 hours, can I then make this new type of product? Should I be investing in productivity? A lot of these questions come. And so just having one static report is not helpful. So doing a lot of this what if analysis is what the sensitivity report helps you with. Yeah. And so how do we go through various examples to just get ourselves familiar with how the sensitivity report works is the goal of this video. Yeah. So that you don't have to keep running this complex analysis, have to ask your data analyst to say, hey, something changed, can you run this again? Well, this is a simple example, but you can imagine a sensitivity report which tells you all the possible ranges that you should be okay with in terms of the decision, in terms of the objective that you care about, is so much helpful, because it could be very complex sometimes to run all of this, to get all of this data, and you might want to run it every day sometimes when a lot of things change. Yeah. But if it's very complex, it's helpful to have some sort of a report that gives us a clear understanding. Yeah. So some sort of a report like this. If you still don't understand the context of this problem, I would recommend you to go to the other video where we've actually solved this entire business problem. We written the mathematical model for this, and then we actually solved it. And so this was a solution, and we also ran the sensitivity report. So let's look at 10 different examples of what kind of questions can come in your business when you're manufacturing these aqua spas, and how do you deal with this? And then what kind of answers does the sensitivity report give us, and what does it not give us? Yeah. So the first question, what is this shadow price of $16.67 stand for? What is that? What is the 16.666, right? What does that stand for? How do I use this constraint that I have on laborers, and what does the 16.666 mean? I'll give a quick pause, think about it. Yeah. What does this 16.66 mean? Shadow price for laborers used as a constraint. So in a sense, 16.67 indicates the magnitude change that you would expect in your objective final value or your optimum value, which is this one here. Yeah, you care about this is your objective. So for every unit change in the laborers, or in this case, let's say this is the hours of labor, if you have a 1 unit increase in this constraint, yeah, okay, we only have 1566 hours of laborers, but what this says is that if you increase this by 1 unit, so 1566 becomes 1567, then you can expect $16 in this case to be added to the profits. Well, that's helpful. So that means that if I add 10 hours, that I could increase my profits by 166. Yeah. So that is very powerful. So you can make decisions, and you also given bounds that says, hey, you can assume this to be true, that you can add $16.66 to your profit and increase your profit as long as you increase this 1566 by maximum of 234. So add 234 until there you can increase and get this value added times the units that you increase. Yeah. So if I have 10 hours added, it'll be 166. Similarly, you can reduce 126 hours and expect that you have to reduce your profits by 16.66 times however many you reduce. So that's the shadow price. It tells you how your objective function, in this case profit maximization, is impacted. Yeah, very powerful. So you can make decisions if sometime you don't have to rerun this complex analysis if all you know is that you're going to have 6 people working, 10 people working 1 hour each more, so it's 10 hours more, so what's going to be the impact? Or 10 people less working in an hour each, you can do the calculation. Yeah. So that's how you use this. And so let's see, we also have one other piece here. So the key thing to remember is as long as that you are within this limits of 234, that's what I've highlighted here. And we also see a shadow price for tubing is 0. Yeah, for tubing constraint, which is this, the shadow price is 0. We looked at shadow price 1666 for labor, but what this says for tubing constraint, the shadow price is 0. Thus, if we don't reduce the tubing by more than 168, our optimal profits will remain the same. Yeah, so same setup. You will have 0 impact on profits as long as you don't reduce it more than 168. So you can reduce 167, 0. But if you go 169, then this range will not work, meaning it will have non-zero impact. So you can assume you have about 168 slack, which is the same as allowable decrease, meaning you've not used these resources. You can use shadow price of 0 to use as an indication of where resources there's a slack, and how you can reduce those resources but still have no impact on because it's 0 per unit decrease. Yeah. So changing constraints for labor, in this case we looked through this. So if we actually moved this up, meaning you remember we have an ability to go from 1566 up to adding 234 more. So let's say we did that. We actually just increased by 10 actually. 1566 went to 1576, yeah? So we had 1566 as our original constraint. What if I made it 1576? Notice that if I increase my right-hand side constraint, meaning I just added more laborers, you will see that my profits increased, yeah, because I can have more people work. And also my quantities, the decision variables have also changed, yeah. So if you remember how we solved this graphically, the feasible region itself changed, and so you will have a different optimal solution and different for different value of optimal solution for the decision variable, and the maximum objective will also be impacted. Yeah. So that's the key but all of this is only useful within those limits. If you go beyond those limits, and if you change more than one constraint at a time, then none of this works. It's assuming only one change at a time, and within those limits, then you can use these bounds to give you a good indication of whether your decision variables would change, when would they change, only changes when you change the constraint, or when your objective changes. Yeah, so that was the first example. Let's look at the second one. What does the reduced cost of minus 13.33 for the decision variable of Typhoon Lagoons mean? Yeah, you see here, there's a minus 13.33 if you were to produce Typhoon Lagoons aquaspas. Yeah, aquaspa is one type of spa, Hydrolux is one type of spa, Typhoon Lagoons is another type of spa. So let's say if you build Typhoon Lagoon spas and you see a minus 13 reduced cost. So you went through shadow price in the first example. Now let's look at reduced cost. What does that mean? Think about it for a minute. Yeah. Pause this video, think about it, see if you get it. If not, come back to this. Minus 13.33 of reduced cost. Well, it implies that the objective coefficient has to reduce by this amount for this decision variable to be considered. So the objective coefficient stands for the profit contribution, yeah? $320. If you remember, if you produce 1 unit of Typhoon Lagoons, it gives you $320 in profits. So that's the same as the objective coefficient, yeah? If you have an objective function, it'll look like 350x1 plus 300x2 plus 320x3. x1 stands for quantities of aquaspa, 122. x2 stands for Hydrolux of, that is 78, right? So what it tells you is that we have a minus 13 value, and your objective coefficient, in this case 320 for Typhoon Lagoons, would have to reduce by this amount. So 320 minus 13. So 320 plus 13 is when you have profit contribution increase to 333. 320 minus 13 reduce by, so minus, and then is a negative amount. So that means the objective coefficient or your profit margin per unit of Typhoon Lagoon has to increase to about 333.34 before it will be produced. Yeah. So what this optimum solution is telling you is to make 0 units of Typhoon Lagoons. But if you wanted to not have it to be 0, meaning you wanted to build one of it, that answers one of the questions. Remember, I started this video where one of the executives were really excited about building 1 unit Typhoon Lagoon. So it's basically saying you will reduce your profits by minus $13 because it's only producing 320 units of profit, $320 of profit. It has to produce at least $333.33 of profit, or the objective function has to increase by 13.34 before it becomes profitable, or before this can become non-zero, meaning you can produce this and be profitable. Yeah. So that's how you interpret this. Yeah. And so in case I actually, set a constraint that says, or if I, let's say, changed my 320 as the objective coefficient to 333.34, slightly above, 1 cent above 333.33. Yeah. If you look at it, if I go from 320 to 320 plus 13.34, look, my solution completely changed. It now says I have to build most of it Typhoon Lagoons, and I'll make more profits. Yeah, slightly more profits, $1 more. Yeah, but it completely changes how much tubing is used. It says you shouldn't be building aquaspas anymore, right? So what happened here is that changing one of these objective coefficients by this reduced cost amount for my decision variable changes my decision variable and also changes my objective function. So super important to note that is how when 320 changes based on recommendations from here, if we increase it, that we would see that the decision changes at the same time the objective profit maximization also changes. And how much does it change by if you actually make a constraint without changing the overall objective coefficient? You keep 320 as is, but you add a constraint that says, hey, I want this to be at least 1, greater than or equal to 1. Yeah, Typhoon Lagoons has to be greater than or equal to 1. I don't want to change my constraint. Then the profit will reduce by 13.33, exactly same as the reduced cost. So you can think about reduced cost as also an opportunity. Yeah, you're actually reducing your profit by 13.33. Yeah, that's your opportunity cost per se. Yeah. All right, so what does shadow price of 0 mean for a given resource? Yeah, we see 0 here. What does that mean? What does the shadow price of 0 mean for a given resource? Again, stop this for 30 seconds, think about it, see if you can get some answers, and then unpause this video and go forward. All right, so when you have a shadow price of 0, that means this resource is in excess supply. Yeah, look at this. It has a slack of 168, and it's telling you that even if you increase this constraint, we're looking at constraint by infinite, then still there'll be no impact. Yeah, meaning you're not even using what you have. You have 2,880. You're only using 2,712. So this points to resources that are in excess supply. Yeah, and you have not utilized these resources fully yet, and they're not contributing to your optimum value. Even if some of these quantities are reduced as much as reducing it by 168, will have no impact on your profits. So that's shadow price of 0 and how it's interpreted. Number 4, what does reduced cost of 0 mean? We went through reduced cost, we went through shadow price of 0. Now let's look at all of these. What does reduced cost of 0 stand for? How do you interpret that? Pause, think about it, take it forward. Well, when you have reduced cost of 0 in this maximization problem where we're maximizing profits, what that tells you is that these decision variables are at the optimum value, and it will have 0 impact. You need 0 changes to the objective coefficient to make any, for them to be included in the decision. So what that also means is when you see reduced cost of 0, these values are optimum values, and these are included in your decisions, meaning you will have non-zero final values for these quantities that you would produce. Yeah, and it's the optimum value. It could be 0 too, but it's the optimum value. This final value is the optimum value. All right, number 5, change in constraint coefficients. What if I told you that I can reduce the hours I need for Typhoon Lagoon production for my laborers from $8 to $7 because I just made them more efficient? How does that impact if I can build Typhoon Lagoons because of this enhanced productivity, and how does that impact my profitability? So that's the question. Pause, think about it, and take it forward. All right, so if $8 were to reduce, 8 hours were to reduce to 7 hours, we can calculate the reduced cost by the equation of the reduced cost is you look at the profits contributed for this unit, which is 320, which is the objective coefficient, which is same as this one. So every unit that you produce will produce $320 of profit. So take out from the profits all the costs associated with building this product. Well, you would need 1 pump, each of which costs you $200, so which you can get it from here, shadow price. You need 7 hours of labor instead of 8, so we're going to reduce 7 hours, and each of these laborers will, have $16.67 that they would require to work for building that Typhoon Lagoon pump, and then you would need 13 units of tubing. And in this case, it's saying, hey, you would use 0 of it, right? So in a sense, your new reduced cost would be positive. It was negative before, now it's going to be positive. So when you have a positive reduced cost because you're just becoming more efficient, it now makes sense to build Typhoon Lagoons. And we now have the solution which is no longer optimal. Yeah, so we'll have to rerun the optimization and we'll have to get the new results. So if we rerun the optimization, we see a change. It now tells us that the profit's much higher, that I should be building aqua spas and Typhoon Lagoons and 0 hydrolux at this efficiency. So a lot of things change here if we did this new optimization run. So you would have to do this new optimization, especially if some of your coefficients are changing, right? Meaning in this case, you're much more efficient with these known variables. So when that changes, you would want to run the new optimization and then check that the profits change and also the decision variables changed. Yeah. All right, sixth one. What is the maximum amount of labor that we can afford to put on Typhoon Lagoons, and is it still economically viable? Yeah. What's the maximum amount we can afford to put? We cannot afford to put 8, and that's why it's telling us to build 0. But what is that minimum value or the maximum value that will make this non-zero? Something affordable. Tell me a value here that can make this non-zero. Pause, think about how you would do it, and then go forward. Well, at reduced cost equals 0, we know that it's an optimal solution. So let's make reduced cost equals 0 for this value that's unknown. Let's make this unknown. So we would say 320, which is the profit for every unit of Typhoon Lagoon, minus the cost associated with using one pump, which is $200, minus X unit of labors, because we don't know how much that is, times 16.66, and then there's 0 times 13, so we're not going to count that. So then we'll solve for X. Yeah. So we will equate this to 0, and we get X equals 7.2. So we now have the optimum hours that we can spend, and we will have non-zero solution. So that's powerful. So if we can build technologies, invest in technology such that our laborers hours goes down, now we have a way to build for Typhoon Lagoons as a product. So that's very helpful. And then what's the constancy principle? Well, the constancy principle says that we can assume that these objective coefficients, in this case 350, can increase by 100, so it can go to 450, and it can reduce by 20, which is 330. So this value can go from 330 to 450, meaning every unit of aqua spa that I produce can make me as low as 330 to as high as 450. Currently it's making 350. So even within this range, my optimal solution will not change. Yeah, that's the key. But assuming that that's the only change I'm making, meaning let's say this goes to 450, every unit now makes $450 in profit, I'll still make the same quantities. I'll not change the quantities because it's within the range. But if I make any other change in any of these other coefficients, then this guidance is not valid. So that's the key. That's the key takeaway. When is this guidance valid? It's only when one variable is changing. Yeah. But if you change more than one variable, then you have to do some more complex calculation, which is you have to look at the proportional change within the limits allowed. And if the total proportional change across all of the variables less than 100%, then you may be still okay, but it's not recommended, not guaranteed. So you'd have to rerun the analysis and cannot reuse this if there's more than one coefficient changing. Very important. So that's the constancy, meaning every other coefficient remains the same. then I can assume to use this limits and change this limits. But if two of these change at the same time, then this doesn't work. You have to with a guaranteed fashion. Yeah. Can we ever have a decision variable that has non-zero final value, like this one, non-zero final value, decision variables? Can we ever have a decision variable that non-zero final value have a non-zero reduced cost, meaning you have a non-zero final value? Can it ever be that the reduced cost is not zero? Think about it. Yeah. Well, let's start with the basic understanding. So variables which have non-zero final value, meaning these variables tell us that we will actually build these products. So these are basic variables. Non-basic variables are variables which we're not going to build, meaning they are equal to zero. Final value is equal to zero, so they're non-basic, meaning we're not ever going to produce Typhoon Lagoons in the optimum solution. So basic variables will always have non-zero final values. Non-basic variables will have zero final values. So regardless of whether you're minimizing or maximizing, in case we are maximizing profits, the reduced cost of basic variable will always be zero. Yeah. Because if it was not zero, yeah, it would contradict the optimality condition. Yeah, because this is an optimum best solution. If this is non-zero, if it's positive, then it would mean that you could actually increase the coefficient, but that's not the case. Yeah, within these constraints, this is optimal. So that's the high level. Yeah, it will always be zero. Reduced cost will always be zero for non-zero final value basic variables. All right, can we have a negative shadow price for a maximization problem? Can we have a negative shadow price for a maximization problem? Yes, you could have a negative, positive, or even zero. Yeah, it just tells you how much per unit would be the impact on the objective if these constraints were changed. So a negative shadow price indicates that the increase in right-hand sides will worsen the objective value. Yeah, so if it's negative, every unit increase will have a negative contribution to the objective function. If it's positive, every relaxation or increase in the right-hand side will have a positive impact on the shadow price, or equal to the shadow price on the objective function. Similar, if it's zero, then it's zero impact. All right, final one. What changes should you expect if you change the objective coefficient of a decision variable? If you change the objective coefficient of a decision variable, and what changes can you expect if you change the constraint right-hand side of the constraints? So if you change objective coefficients of the decision variables, and if you change the constraint right-hand side for constraints, what are all the changes you could expect? Think about it. All right. So when you change the objective coefficient within the allowable increase and decrease, so assuming you change this but within this range, then you would not impact the optimal decision variables, but you would certainly impact the profits. Yeah. So you would impact the final value of the objective, but as long as it's within this range, you will not impact the decision variables will not change. You will still produce the same amount. And if you change the right-hand side, which is you change the constraints, then I think all of this will change. You will change the decision, because the feasible region itself is changing. So your decision variables may change, your objective will also change, profits may also change. All right, so those are the 10 situations. So now you understand different ways to look at and answer what happens if there's more laborers, if they're more productive, what happens if you invest more in some of these constraints and increase the limiting constraints, and should you expect to change the quantity of goods that you produce? Would you have higher profit margin for a product? Would you increase the profits, or would you change, and when would you change? Yeah, so within the allowable limits you can use it, but if you go above the or below the limits, then you have to rerun the calculations. So that is super helpful to understand how to use the sensitivity report and answer so many of these real life business questions as to what if this happened, what if that happened, and changes is the fact of life. And so you would have different kinds of questions Tell me in comments, what kind of questions do you use to use the sensitivity report for, and how you found it useful. Thanks.